Hi guys, welcome to chapter 20. We're going to cover section A today. Chapter 20 is all about like storms and severe weather. So we've talked about weather in general. Now we're going to talk about more extreme weather, okay? And before we get into the actual storms itself, we're going to talk about some different characteristics of the atmosphere, okay? So air masses are kind of like exactly what they sound like. It's a huge mass of air, but it has similar qualities, temperature and humidity. Okay, but temperature is more prevalent when we talk about just the cold air mass, warm air mass. Okay, a source region is basically the ground or the surface. It could be the ocean, the surface of the Earth directly below the air mass. Okay, and that determines what those properties of the air mass will be. Again, we're looking at humidity and temperature. So we've got five main air masses that we talk about. Okay, these five right here. Now, the first word, continental versus maritime, tells you whether it formed over land, continental, or over the ocean, maritime. If the air mass is over the land, that means it's dry. That's a description of its humidity. If it formed over the ocean, it's called maritime. That means it's going to be humid. It's going to have more moisture in it, okay? And then the second word, Arctic, polar, or tropical, is a description of how cold it is, okay? So continental Arctic is formed over land. It's very dry and very cold. Continental polar, formed over land, so it's dry, and cold, polar. Continental tropical, formed over land, so it's dry, but now tropical means warm, okay? That's closer to the equator. Then we have maritime polar, so it's humid, it's formed over the ocean, but it's cold. And then maritime tropical, over the ocean, so it's humid, but warm, okay? That's how the air masses work. Now, these air masses might actually interact with each other, and that's what a front is. When two air masses come into contact with each other, if they're different, they don't play well with each other, they don't mix. If two similar air masses come together, then you can't really tell the difference. But a lot of times we get different kinds of air masses coming together. The four main air masses we have are stationary, warm, cold, and occluded. Okay. Stationary front is down here, and I'm a little bit in the way. You're not really missing much right there. But basically, what happens is it's just when two air masses come into contact with each other, and they really don't change each other at all. They kind of get stuck. They're stationary. They don't move. All right. A warm front and cold front result in the same thing. Okay. Remember, if you've got warm air and you've got cold air, the warm air is going to rise. It's less dense. It's going to float on top of the cold air. Okay. So with a warm front, it's the warm air mass that's moving. It crashes into a cold front and it goes above it. That's a warm front. Cold front, same thing results, but it's the cold air mass that's moving. So the cold air mass comes in, crashes into the warm front, and goes under it. Okay, so the result is that warm air still goes up. And then finally, an occluded front, that fourth one down here, is a little more complicated. It occurs when two cold fronts come in and kind of capture a warm front in the middle. Those actually tend to bring a lot of rain. Okay, all right. Now, we talked about clouds in a previous chapter. We're talking about storms. Storms don't occur without clouds. So the question is, why do clouds form? We talked about how clouds form, but why do they form? And all four of these reasons, convection, orographic lifting, frontal wedging, and convergence, all result in warm air rising, taking moisture with it. It gets cooler as it goes up into the atmosphere, allowing that moisture, that water vapor to condense and form clouds. As the condensation keeps going, the droplets of water get bigger and precipitation can fall, okay? But there's different ways that warm air might rise. One of the most common is convection, okay? That's hot air rises, okay? That's the demonstrations we've done in class that has to do with the density of warm air. Basically, warm air just naturally rises. So you can get these things called convection clouds. And in some locations, these things will form every single afternoon, and it will rain every single afternoon in certain areas. Flat, hot areas, okay? So the hot air rises, there's enough moisture in it. As it rises up, it cools, it condenses, and it falls back to Earth. It's like this own little mini water cycle in one location, okay? So convection is one reason. Orographic lifting, and you can see kind of the explanation of this on the bottom of page 479. This occurs with mountains. So as air is moving, okay, it might bump into a mountain. And so the actual shape of the mountain will cause that air to rise. If it's warm and moist air, it's going to rise up this mountain. Guess what? It's cooler up there. That's going to cause clouds to form and potentially weather, potentially storms. This is why mountains tend to get a lot of snow and a lot of precipitation, okay? Because it's colder. The higher altitude, it's colder. So the warm, moist air goes up the mountain, condenses, it forms clouds. This is known as the windward side of the mountain. It's facing the wind. The wind is blowing this way. And you can notice this is a little bit of an exaggeration, but look at how green that side of the mountain is. It gets all the precipitation. By the time the cloud gets over here, it's run out of all of its precipitation, okay? And so you get somewhat of a deserty region on the leeward side of the mountain, okay? There's not enough moisture left in the cloud. The cloud kind of loses its shape and structure. And this is known as the leeward side of the mountain, okay? We also get something known as frontal wedging. And basically, it's just when fronts come together. Most dramatically with cold fronts. Cold front comes in, boom, pushes a warm front up. That warm air cools down. Water can condense, clouds form, potentially storms, okay? And then finally, convergence. Convergence is something when wind coming from opposing directions, horizontal wind, crashes into itself. This happens in areas that might be surrounded by water. So if you think of the state of Florida, off on the edge of the edge of the continent, we've got wind coming in this side, we've got wind coming in this side, and it's going to crash into itself on Florida right there. When that wind crashes, it actually causes air to lift above it. Okay, so that's just another boost of that warmer, moisture air going up into the higher altitude of the atmosphere and then condensing. Okay, I believe that's all. See you later.